Hello, this is ICP-10, which is a deep learning ICP-3. So in this ICP, our objectives are to find the mistakes in the code and run it and observe the output. And the second one is adding the embedded layer. And third one is like the third task is to find the loss and accuracy. So in this ICP, we are going to use the IMDb master CSV file. As you can see, as we did in all the ICPs, I'm first reading the CSV file and loading it into the df variable. After that, df.head5. This syntax here take the first five columns of the CSV file. Later, in the y variable in here, this in the sentences variable, I'm going to review I'm going to take the values of the data I have, and after that I'm going to label them, encode them, and after that I'm going to save them in the y variable. After, I'm going to tokenize the data I have. The tokenize in the tokenize, it's going to be 2000 words. Like, the tokenization is going to be done to 2000 words. After that, the tokenization is done for the sentences variable, and it is also again saved in the sentences variable. After that, I'm going to encode it, to convert the non numeric values to the similar data types. After that, I'm going to transform it, and I'm going to save it in the y variable after I'm applying the train test plate. After that, I'm going to use the sequential model here. I'm going to add the dense layer, like the hidden layers here. Like, the first mistake in the ICP is that they did not mention the input dimensions, and input dimensions should be equal to the number of columns. So they did not mention it, and we are going to add the input dimensions here. And after that, I'm going to add another dense layer and compiling it. After that, I'm going to fit the xtrain and ytrain values into this model, and I'm going to print, evaluate the prediction, and after that I'm going to print the accuracy. So actually, this I see, this program, this model takes a lot of time to run the data because the data is so big. So I have already run the data here, and as you can see, it has run all the samples in the 5 of the columns, and each and every column has its own loss and accuracy, and the final accuracy is 0.49. So the next part is to add the embedded layer here. So as you see, I have again printing the first 5 columns of the data. After that, I'm encoding it and saving it in the y variable. After that, I'm going to the tokenizing of the data, and after that, train test splitting. And in the tokens, xtrain tokens, I'm going to tokenize the xtrain, and this data is going to be stored in the xtrain tokens as like that. I did tokenizing to test and train data sets, and they are saved in different data variables. So after I did the padding, and I have saved it in the padded train and padded test variables. After that, again I'm going to uh, feed this data to my model, and I'm going to evaluate the padded test and y test, which is gonna be our predicted output. And after that, I'm going to print the test accuracy. So the results, actually this one is also the first part. I'm not adding the embedded layer here, as you see. Just a minute. I'm gonna plot the data. As you see here, I'm going to print the first 5 columns, and after that I'm going to find out the loss and accuracy for each column, and this is the final accuracy. So from the next, after adding the after gonna add the embedded layer here, I'm going to use the new 20 news groups dataset. So here in the cats variable, I'm going to take these 2 columns, and after that in the df variable I'm going to add the data of continuous groups, and in the sentences I'm going to add the data of df like from the df variable, and the target variable is gonna be train column, and this variable I'm gonna fix it into y. After that I'm encoding it and transforming it, and saving it in the y variable. After I'm tokenizing it up to the 2000 words, and after that train test splitting and transforming both the test data and train data and saving them into different variables. After that I'm going to feed them into my model. So here you can see the model that add embedding. Here I'm going to add the embedding layer, which will help you to find the accuracy of the data, like more like it helps you to predict the accuracy well, to predict the output well. So that's why we use the embedding layer. After that I'm going to add the flatten layer, and after the hidden layers, and I'm going to evaluate the test values, and I'm going to print the accuracy, and I'm going to plot both of the values. So as you see, I have got the accuracy as 0.59, and these are the both of these are the plotted accuracy. This is the plot for accuracy, and this is plot for the loss. And the next one, here we are gonna find the loss and accuracy for the 20 news groups dataset. After applying all the embedded layers, and we are using the sequential model here too. So as you see, I did the same thing, but here the X model, I'm going to print the predicted values accuracy. So as you see, I have run the data, and this is my output, the final output. Like this is gonna be run for 2 columns. So for that the model gonna take 804 samples, and it is running for each and every column. In the final, yes, you see accuracy is 0.5, and the loss is also loss is 6.5, and the prediction should be, the prediction is 0. The actual prediction is 0, but the predicted prediction is 1. So as we see, the model is like not so good. So this is the final IC, like this is the ICP 3 in the deep learning. So that's all for today. Thank you.